Hi, welcome to Tech. Rangarajan, Dr. Sagundala, R&D Institute of Science and Technology. This is SCR, Assistant Professor from Department of ECE. This video, I will explain you the construction, the symbol, equivalent circuit, operating modes, and applications of one of the special semiconductor device called silicon controlled rectifier, shortly known as SCR. Before getting into the topic, we will discuss some important features or key features of this SCR. Basically, an SCR is a 4-layer PNP semiconductor device. Sometimes this SCR is called as thyristor, and generally an SCR is made of silicon. You should know why silicon material is used in the fabrication of SCR compared to the germanium. The reasons are multifold. The first main reason is the silicon material has smaller leakage current at room temperature, and the second reason is it is not easily get damaged by excess heat. Then the third reason is it has greater peak inverse voltage rating, that is PIV rating, and the next one is it is less expensive than the germanium material. Here I have listed few reasons for choosing silicon over the germanium. Now we will discuss the construction of the SCR. As I said earlier, it is a 4-layer PNP device. So the 4 layers are arranged like this. Moreover, it consists of 3 terminals called anode, cathode and gate. They are represented by the variables A, K and G, and you should know from where to derive the anode terminal, cathode terminal and the gate terminal, because here we have 4 semiconductor layers, but we need to derive only 3 terminals. So it is important to know from where to derive anode, cathode and gate. By looking this constructional diagram, one can understand that the anode terminal is derived from the top P material and the cathode terminal is derived from the bottom N material, and the gate terminal is derived from the P material, which is very close to the cathode terminal. And apart from these 3 terminals, this SCR consists of 3 PN junctions called J1, J2 and J3. Now we can see the symbol of SCR. This is the symbolic representation of SCR, where we mark the anode and cathode here and the gate terminal here. So this is the symbol of SCR. Now we will discuss the 2 transistor equivalent of SCR. Why this is so called 2 transistor equivalent of SCR? In the sense, the entire 4-layer PNP structure is divided into 2 bipolar junction transistors as one PNP and one NPN. Hence, it is called 2 transistor equivalent of SCR. I will tell you or show you how to derive or draw the 2 transistor equivalent of SCR. First, we can take the constructional diagram of SCR. This is the constructional diagram of SCR, or you can say the basic structure of this SCR. Now, to derive the 2 transistor model of SCR, we need to split or we need to divide the inner layers, that is this N layer and this P layer, into 2 halves, so that one can get 2 bipolar junction transistors as one PNP and one NPN. If you are talking about bipolar junction transistors, then definitely you can come across the terminals of bipolar junction transistor. We know that they are emitter, base and collector. Now we can go for assigning the terminals to the PNP and the NPN transistors. On taking this PNP transistor, this P material is equivalent to the emitter terminal, this N material is equivalent to the base terminal, this P is collector terminal. Coming to the NPN transistor, this is the emitter terminal, this P material is equivalent to the base of the NPN transistor, then the collector of the NPN transistor is given by this N-type material. So this is the 2 transistor equivalent of SCR by means of the constructional diagram. Now we can try to derive the same by using the symbol of the transistor. As we know that this is the symbol of PNP transistor and this is the symbol of NPN transistor. Now we can mark the anode, cathode and gate. You should know from where or at what point we need to mark the anode terminal. If you are looking this 2 transistor model of SCR, the anode is derived from this P material, whereas this P material is nothing but the emitter of PNP transistor. So on emitter of the PNP transistor, you can mark the anode terminal. Then coming to the cathode terminal is derived from the emitter of NPN transistor. So here we have the NPN transistor. This is the emitter terminal of the NPN transistor. So you can mark the cathode terminal here, and you know that the gate is derived from this p-type material. Basically this p-type material is a single p-type material, but coming to the 2 transistor model, we divided or we splitted that into 2 halves. One is collector of PNP, another one is base of the NPN transistor. So we need to identify a mark where the collector of PNP and the base of the NPN are joining or meeting. If you are taking the terminals, this is the collector of PNP, this is the base of the NPN transistor. So we can mark the gate terminal here. We just assume that the anode current is flowing by this way and gate current is flowing by this way, and the cathode current, we can say IK, is flowing by this way. So this is about the 2 transistor equivalent of SCR. Now we can see the operating modes of SCR. There are 3 operating modes. This means that one can operate an SCR in any one of the following 3 modes. The first mode is forward blocking mode. The second one is reverse blocking mode. Then the third one is forward conduction mode. We will see one by one. First I will explain you the characteristics of SCR under forward blocking mode. I am going to explain you with the help of the constructional diagram of SCR. So this is the constructional diagram of SCR, where we mark the terminals anode, cathode and gate, and even we mark the junctions J1, J2 and J3. The characteristics graph of SCR is a graph drawn between the voltage and the current, exactly saying in the sense it is the voltage applied across the anode and the cathode terminals. So I am taking the VAK voltage on x-axis and the current, that is anode current, on the y-axis. First we can see the forward blocking mode. What do you mean by forward blocking mode? In the sense, in this forward blocking mode, the anode terminal is connected to the positive terminal of the battery and the cathode is connected to the negative terminal of the battery, and nothing is connected to the gate, or you can say the gate is kept open in this forward blocking mode. Now we can see what will happen if you are increasing this VAK from 0 volts onwards. Before that, you have to remember, because of this kind of supply connected to the anode and cathode terminal, this leads to forward biasing of junction J1 and J3 and reverse biasing of junction J2. So under this mode, junction J1 and J3 are under forward bias condition, whereas junction J2 is under reverse bias condition. Now we will try to increase the voltage applied across anode and the cathode terminal from 0 onwards. If you are increasing the voltage applied across the anode and the cathode terminals, you can get a current flow through the SCR, but this current is due to the movement of the minority charge carriers. So you can say only a small leakage current flows from anode to cathode, that is indicated by this region. Otherwise you can say it offers very high resistance to the flow of current because of this reverse biased junction J2, but one can under this mode, or at this point we can say the SCR is said to be in off state, but one can bring the SCR from off state to on state by applying more anode to cathode voltage, or you can say if you are increasing the VAK voltage from 0 onwards, once it reaches certain voltage called the breakover voltage, the junction J2 undergoes avalanche breakdown and SCR starts conducting the current from anode to cathode. So this VBO is called the breakover voltage. The range of VBO is from 50 volt to 500 volt. So this is one way of bringing the SCR from off state to on state, but usually we are not interested on this way of turning on the SCR because we need to apply a very high voltage across the anode and cathode. We know that this VBO is nothing but one of the voltage that is applied across the anode and cathode terminal. It's one of the VAK voltage, but the range, if you are looking the range, you can get the idea about why we are not going for turning on this SCR by this way, because we need to apply a very high voltage between the anode and cathode terminals to bring the SCR into on state from the off state. So you can say this is the characteristics curve of SCR, or Ig equal to 0. Since the gate is kept open, hence I am writing Ig equal to 0 here. Now we can see the characteristics of same SCR under reverse blocking mode. So what is the difference between the forward blocking mode and the reverse blocking mode? In the sense, just reversing the supply voltage connected between the anode and cathode terminals. That is, the anode terminal is connected to the negative potential of the battery and the cathode terminal is connected to the positive potential or positive terminal of the battery, and gate is again kept open, that is nothing is connected to the gate terminal. Now you can see what will happen if you are establishing this kind of connection between the anode and the cathode. We can say easily that here this diagram looks like two diodes are connected in series with reverse voltage applied across them, and moreover, due to the application of this negative voltage to the p-type material and positive voltage to the n-type material, this leads to the reverse biasing of junctions J1 and J3 and forward biasing of the junction J2. So under this condition, junction J1 and J3 are said to be in reverse bias condition, whereas junction J2 is said to be in forward bias condition. Now we can see what will happen if you are increasing this VAK voltage. Here we reverse the polarity of VAK, hence the application of voltage is going to be in the reverse direction. So you can keep on increasing the VAK voltage in the reverse direction, that is negative direction. So if you are increasing the VAK voltage from 0 onwards in the negative direction, then a small leakage current of the order of a few milliamperes or a few microamperes will flow from anode to cathode. And if you are keep on increasing the reverse voltage applied across the anode to cathode, the junction becomes, the junction got break down at a special voltage called BPR, or you can say breakdown voltage. So the breakdown has occurred at this BPR voltage, that is breakdown voltage. At this moment, maximum current will flow through the SCR from anode to cathode. Remember that this current is due to only the movement of minority charge carriers, so we are not going to take this into the consideration. Hence, the SCR is said to be in off state under this reverse blocking mode. Now, we can see the characteristics of SCR under forward conduction mode. There is a similarity between forward blocking mode and forward conduction mode. That is, in case of forward blocking mode, we connected anode to positive terminal of the battery and cathode to the negative terminal of the battery. In this forward conduction mode also, we need to connect the anode to positive and the cathode to negative terminal of the battery. Apart from this connection, we need to connect a positive supply voltage to the gate terminal of the SCR. So we connected here a positive potential to the gate of the SCR. So this is the connection to be established for this forward conduction mode. With this setup, we know that the junctions J1 and J3 are forward biased, whereas junction J2 is reverse biased, because we connected anode to positive and cathode to negative. But by applying a suitable gate voltage, that is a suitable positive gate voltage to this p-type material, we can bring the junction J2 to forward bias condition. At this condition, we can say all these three junctions, say J1, J2 and J3 are under forward bias condition. So the current corresponding to the current VG voltage is IG1. Now we can see the characteristics of SCR for this VG. If you are increasing the anode to cathode voltage from 0 onwards, a minimum current will flow through the SCR, and once this VAK voltage reaches the breakover voltage, say VBO1, the SCR is brought to the on state so that a current is flowing from anode to cathode of this SCR with very small voltage drop across it. This state we can say on state, or you can say the SCR is now in on state. So this is the characteristics curve of SCR for IG1. Now we can see what happened when you are increasing this VG such that the IG2 is greater than IG1. For this IG2, the VBO will occur earlier than this VBO1. So this VBO2 is lesser than that of this VBO1, and this VBO1 is lesser than that of this VBO for IG equal to 0. So this is the characteristics of SCR under forward conduction mode. The thing you have to remember is, if you are increasing the gate voltage, the occurrence of the VBO is going to be earlier than the previous gate voltage. Since we are controlling the current flow through the SCR by setting the gate current, hence it is called the current controlled device. From the previous analysis, one can say that a thyristor may be brought from forward blocking mode, that is off mode, to a forward conduction mode, that is on mode, by two ways. One is by exceeding the forward breakover voltage, that is VBO. The next method is applying a positive gate pulse between gate and cathode, and moreover the gate loses its control once the SCR is triggered. Once the SCR is turned on, then gate loses all its control. Now we will see the terminologies used in this SCR characteristics. The first is the latching current IL. It is defined as the minimum anode current required to turn on the SCR. I will show you where the IL current is marked in the characteristics graph. So this is the position of the IL current, that is the latching current. This means that this is the minimum amount of current we need to turn on the SCR. The next term is the holding current IH. It is defined as the minimum anode current required to maintain the thyristor in the on state. See the difference between the latching current and the holding current. This is the minimum current required to turn on the SCR. Once that SCR is turned on, then we need to maintain the SCR in the on state by maintaining a minimum anode current, which is nothing but the holding current. So the position of the holding current is going to be this one. From this we can say the holding current is less than the latching current, or otherwise you can say the latching current is greater than the holding current. And one more thing, you can say the latching current is related with turn on process, while the holding current is related with turn off process. Now the important thing is turning off methods of an SCR, because once the SCR is turned on, then we cannot blindly go for turning up the SCR. So here some methods are suggested for turning up the SCR. The methods are natural commutation, reverse bias turn off method, then the third one is gate turn off method. Now I will explain you how one can turn off the SCR by using this natural commutation method, reverse bias turn off method and gate turn off method. What is natural commutation in the sense? It is the process of reducing the current which is flowing through the SCR below a minimum value or the holding current. So this is one way of turning off an SCR, just by reducing the current flow through the SCR below the rated holding current. Thereby one can turn off the SCR. According to the reverse bias turn off method, by reversing the voltage applied to anode and cathode, one can easily turn off the SCR. Then the third method is gate turn off method. In this mode, just by applying a negative pulse at gate, one can turn off easily the SCR. So these three are the methods suggested for turning off an SCR. At last, we can see the applications of SCR. The SCR is used in power switching circuits. It is both AC and DC power switching circuits, and it is used in zero voltage switching circuits, and it is also used in over voltage protection circuits. It is used in inverters also, and it is used in AC power control circuits, and moreover the SCR is used in timing circuits and temperature control systems. So these are all the applications of SCR. So that's all about the construction, equivalent circuit, symbol, operating modes of SCR, and the applications of SCR. Thank you for watching this video.